identifiers. So now I can use this DTO in my habit tags controller, and let's assign it a name. So now I have something to work with. Let's update the name of my second endpoint to be delete habit tag, and I will update the name of the route parameter to match the habit identifier. And now let's see what we need to do to implement this functionality. I'm going to inject the database context, and then let's start with our put endpoint. We can begin by trying to retrieve the habit from the database. So I can say database context, habits. I'm going to include the navigation property to the habit tags collection because this is what I'm modifying inside of this endpoint. And then let's add a condition that we want to retrieve the first habit where we match this identifier. If the habit is null, then we can go ahead and return a 404 not found response. At this point, we may want to check if the request that we have received already contains the identical state that we have in the habit tags collection. If that is the case, then we don't need to perform any additional updates. So I can say something like current tag IDs, and I want to extract the tag identifiers from the habit tag collection. Now I'm going to convert this into a hash set, and this will allow me to say current tag IDs set equals, and now I can specify the collection that I want to compare this to. And I'm going to compare this to the tag IDs that are present on the upsert habit tags DTO. If these collections are the same, then there is nothing else to do, and we can return, for example, 204 no content. The next thing I want to do is to verify if all of the specified tag IDs actually exist inside of my database. And I can do this by sending another query to the tags collection where the upsert habit tags DTO tag IDs contains the specific tag ID, and I want to project this to just return the specific ID value, and for example we can map this back to a list. And if the existing tag IDs don't have the same number of elements as the number of IDs that we got in our request, then we can return a 400 bad request. This means that we have received a tag identifier that doesn't exist inside of our database. Let's return an error message saying one or more tag IDs is invalid. And finally, if we make it past all of our preconditions, then we can implement the actual upsert logic. So what do we want to do here? Well, we already have the habit tags collection, and we first want to remove any habit tag entries which aren't present in the tag IDs collection on our upsert DTO. So if this collection doesn't contain the tag identifier, we're going to remove them, and I have a handy helper method on the C# list type called remove all that allows me to implement this. And then I just need to extract a collection of tag IDs to add, and these are going to be all of the tag IDs present on the tag IDs collection except the current tag IDs that I have already extracted. So now that we have this, I can go ahead and do an add range operation and map this into my habit tags collection. Finally, I can say database context, save changes async, and then EF Core will take care of properly mapping this into the database. One thing that is missing from the code completion here is specifying the current date and time. So I'm going to add that manually, and this completes our upsert endpoint. Now, why did I call it upsert? Well, this is because I'm supporting an update or an insert if the provided value doesn't exist, and we are also automatically removing any resources that have been removed as part of the request. So this is a true replacement operation in terms of the HTTP put method. I'll demonstrate how this works in just a moment, but let's also implement our delete endpoint. Let me drop in the implementation, and then we can discuss what I have here. I'm performing a database query to select a habit tag entity based on the habit ID and the tag identifier. If it doesn't exist, we return a 404 not found response, and if it does exist, we can just remove it and return 204 no content. So now let's start our application and try out these two new endpoints. Here's what the put endpoint for upserting the habit tags will look like. I specified the habit ID as a parameter, and it's pointing to an existing habit. In the request body, I have a tag IDs collection that contains 4 tags that I want to associate with this habit. If I go ahead and send this request, it's going to land on the breakpoint in the upsert method, and we're first going to retrieve the habit from the database. Now, if I take a look at what we have here, you will see that the habit tags collection is empty. So I currently do not have any tags associated with this habit. We're going to check if this request is identical to what we already have as the state of our resource, and because it's not, we're going to proceed to validate if we have all of these tags available in the database. So you can see that the counts of the existing tags collection and the new ones that we want to add match, so our validation passes. Then we're going to remove any tags that aren't part of our upsert request, and we're going to add the new tag identifiers, of which we have 4 in this example. So let's go ahead and add those, and we're going to call save changes and persist this, and we should get back a 200 OK response. Now it might be more appropriate to return 204 no content. I will update this in the background, but let's send this same request again. We're again going to land on the same breakpoint, and this time, if I take a look at the habit tags collection, you can see that we have 4 entities inside. Now in this example, they're going to exactly match what we already have on the resource, so there is no work left to do. So I can say continue and get a response back in Postman. Now let's say I want to remove one of the tags and send another upsert request. We again land on the breakpoint, and this time you will see that there is some work to do. So we're going to remove the one tag that we omitted in the request. There is nothing new to add, so this is going to be like a no op, and when I perform save changes, it's going to delete the respective record from the database. If you want to gain a better understanding of what is going on under the hood, you can always jump into the distributed traces inside of the Aspire dashboard or the Seek dashboard and take a look at the request that you just sent. Now in this example here, I'm performing a couple of updates on my database in order to implement this upsert functionality. So you can see there's a query to select the habit together with its associated habit tags. Then there is another query for validating the tags, and there is a delete statement that is sent in the end to remove the habit that we omitted from the upsert request. If you want to delete just a specific tag, you can use the delete endpoint, where we can specify the habit identifier and the tag identifier. And if I send this request to my API, we're going to hit the breakpoint in the respective endpoint, fetch the entity from the database, and just remove it. So I can go ahead and press continue, and we should get back a 204 no content response. If I send the same request again, we're going to get back a 404 not found because such a resource no longer exists. And one more thing that we should consider is updating the representation of our resource. For example, a single habit to include any associated tags. Let's say I want to support exposing the tags of a specific habit, but only in the get endpoint that returns a single habit instance. Now we already have the habit DTO, that is the representation of this resource, and if we wanted to introduce the tags as part of this DTO, then we would be updating all of the other endpoints that are using this DTO. So you have a couple of options here. One of them is duplicating the habit DTO and introducing a new DTO for this new representation. So let me create a duplicate, and then let's call this habit with tags DTO. And what I can do here is include a required collection. For example, we can call it tags, and this could represent the tag names that I want to return together with the habit. If you want to avoid all of this duplication, then you can unmark the habit DTO as sealed and make the new DTO inherit the old one. That way we're going to reuse all of the properties that we already have, and we can just introduce the new ones on a new DTO. This will introduce some nuances when it comes to serialization if you want to pay attention to that. For example, the tags property is now going to be always serialized as the first property of this DTO, and you can control this using the JSON property attribute. There's a respective overload. This is the Newtonsoft JSON variant. There's also another one in the system text JSON namespace. And here I could set the order to something like int max value to always force this property to be at the end of the collection. But let's say I want to duplicate my DTO because I don't want them to be coupled in any way. So let's go ahead and extract it into a separate file. So now that we have our DTO, what are we going to do with it? Let's update the getHabit endpoint to return this new DTO instance, and I will quickly run into a problem with my projection. If I go inside, this is my habit queries helper class, I have a projection defined that maps from my habit entity into the habit DTO. But now I have a new DTO. So how can we solve this? Well, all we need is a different projection. So let's, for example, call this project to habit with tags DTO for lack of a better name. And I have to update this to return a habit with tags DTO. Let's also update this. And then what are we missing here? Because of the required member that I defined on this new DTO, I'm notified that my tags property is uninitialized. So I can go ahead and say tags and then map this from the tags navigation collection. And I just want to project the name of the tag into an array on my new DTO. So I can now go ahead and use this new projection inside of my controller, and now everything will compile. So let's go ahead and start the application. And let me first send a request to fetch all of the habits that I currently have inside of the system. And you can see that on the response that I get back, it is just the habits representation. There is no tags property present. But if I take a look at my second endpoint, we're fetching a habit based on its identifier, and assuming I specified the correct habit identifier, you can see that I'm getting back a collection of tags. These are the tags that we assigned to the habit in our put endpoint that we implemented earlier, and now we are exposing these tags when retrieving a single habit. Now we are going to talk more about the different representations of the same resource in one of our upcoming lessons, but I just wanted to highlight that you can return a different response from different endpoints. In both examples, we are representing the habit DTO, except when you fetch a single habit, you get a more rich response. Now here, we are omitting the identifiers of the specific habits, which could be useful if we wanted to be able to remove them. This is something that we will update when we discuss HateOS and Hypermedia in more detail. When it comes to naming your query methods, what I did here was include the name of the DTO into the method itself. An alternative that you could consider is calling this project to DTO with tags instead of mentioning the habits directly, because this is already dealing with the habit resource and it's kind of implied. Obviously, naming things is one of the hardest problems in software engineering, so I'm going to leave it up to you which specific name you will choose. I think we can slowly begin to wrap up this lesson. We covered a lot of topics when it comes to working with child resources inside of our RESTful API. We also touched on the topic of our upcoming lesson a little bit while we were implementing the upsert endpoint, but in the next lesson, we're going to take a deep dive into validation inside of RESTful APIs, and I'm going to show you a couple of different approaches that you can use to implement validation.